Okay, let's try and attempt this problem. 75% of high school students arrive on time to school. Of those, 85% take the bus. 10% of all late students take the bus. To the nearest percent, state the probability that a student who takes the bus to school will arrive on time. So essentially what this question is asking for is, what is the probability that given a student is on time, that they take the bus? So I can write this as P of on time given they take the bus. Now, according to Bayes' theorem and Bayes' rule, he states that the P of A given B is equal to the P of B given A times the P of A over the P of B. Okay? So what we're going to do is make a tree diagram here, right? So we have all high school students, right? And 75% of high school students arrive on time to school. Okay. So we are going to make, here's 75, here's 25. Here's arrive on time, so arrive on time. And here's not arrive on time. Now it says of the people who arrive on time, 85% of them take the bus. That must mean that 15% don't. So this is take bus, don't take bus. And then it says 10% of all late students, 10% of all late students take the bus. So now I can do this. Here's 0.10. And here's 0.9. Here's take bus. Here's don't take bus. Now we want to state the probability that a student who takes the bus to school will arrive on time. So this is the P of B given A. So now I can essentially write the P of on time given a bus is equal to P of bus given on time times P of on time over P of bus. So the P of bus given on time, well, here's arrive on time, and the probability that they take a bus given that they arrived on time is 85%. So here's 0.85 times P of on time. Now there's two ways a student can arrive on time. They can either arrive on time or no. So this is just the P of arriving on time, right? So this is simply going to be 0.75, right? And then the probability that a student takes the bus. Now there's two ways for a student to take the bus. There's this one and there's this one. So this is going to be calculated as 0.75 times 0.85 plus 0.25 times 0.10. And this, I'm going to get out my calculator. Let's do 0.85 times 0.75 divided by 0.75 times 0.85 plus 0.25 times 0.1. And I get approximately 96% when I multiply this result by 100. And therefore, my answer is that the P of on time given bus is approximately 96%. Tricky question.